Historically, physical mechanics and ethical philosophy occupied separate worlds. The Enlightenment established epistemic boundaries that kept the measurable world of force and matter strictly apart from the subjective world of human values. Classical physics describes an arena of inert mass and vector forces. Under these time-symmetric laws, good and evil are treated as psychological artifacts, subjective human overlays with no presence in the physical record. Conversely, ethical frameworks from Kant to Bentham tried to quantify moral value through abstract logic or human pleasure. Yet these formulas remain tied to biological feelings, lacking any grounding in the physical laws that govern the rest of the universe. The framework of Panmorphism shifts this perspective by treating information as the underlying structure of reality. The universe functions as a dynamic topology where complex forms interact across varying levels of informational viscosity. If an entity's existence depends on its ability to navigate its environment, then reducing its available paths diminishes its functional capacity. In this model, the volume of accessible future states provides a measurable metric of potential. Ethics, then, becomes the study of geometric operators that either grow or shrink that volume for others. To calculate these changes, we use phase space, a mathematical boundary containing every physically possible future state an individual can reach. This volume represents the sum of every choice and state currently accessible. Every glowing node is a degree of freedom waiting to be navigated. Take the scenario of a musician whose instrument is stolen by a mugger. In this model, the theft is an application of the operator of evil. The mugger acts as an entropic force. By removing a vital tool, they actively contract the victim's phase space. Trajectories like practicing or performing are erased. This forced reduction in possibility creates a highly constrained timeline, rerouting energy into a narrow tunnel of survival. At the extreme limit, such as in the case of murder, the entity's accessible state space is reduced to exactly zero. All degrees of freedom are extinguished. Evil is defined here as the objective physical destruction of another entity's potential. It is the geometric act of collapsing the future. Now consider a different interaction. A teacher provides a new instrument to a struggling student. This is a direct transfer of opportunity across the system. This action serves as the operator of good. By providing means to navigate new states, the teacher expands the student's manifold, injecting new degrees of freedom. This expansion is autocatalytic. The student accesses pathways of teaching and sharing, generating more possibilities and creating a growth pattern that sustains itself. Because this interaction adds new volume to the system, the combined value of the teacher and student becomes greater than the sum of what they could achieve alone. Expanding the possibility space of interacting forms is the topological definition of good. Cooperation creates a measurable increase in the system's total potential. If we apply this to the scale of civilization, a paradox emerges. If good is the expansion of possibilities, does the reach of our technology make us a more moral society? Technology scales our admissibility domain, the range of what we can physically do. Globalized digital finance, for example, pushed this domain to a global scale. This expansion created massive synergy, allowing capital to move instantaneously to where it could create the most opportunity. But that same geometric growth created the room for new, complex evils. The same digital infrastructure that enables global trade also provides the parameters for automated market manipulation and ransomware. Progress doesn't eliminate destructive operators. Instead, as a civilization grows, the stakes of both synergistic and entropic actions scale with the system's complexity. Restrictive acts create systemic friction known as ontological pain, a thermodynamic signal of high energy consumption. To survive, the system must move toward the path of least structural resistance. This is the principle of least ontological action, favoring expansion over high-cost conflicts. This framework changes how we evaluate daily interactions. Instead of weighing abstract moral intent, we can look through a geometric lens and ask a single question. Did your choice today shrink the universe for someone else, or did you expand it?